Hello students, welcome to Marine Engineering Tutorials. Today our BTech final year students are giving a demonstration on steering gear. I hope you will find the demonstration interesting and informative.
Hello everyone, my name is Prince Kumar.
Hello everyone, my name is Avinash Kumar.
Hello everyone, my name is Arsh Chambyal. We are currently pursuing BTech in Marine Engineering from International Maritime Institute, Greater Noida. We have made a working model of 4-ram electro-hydraulic steering gear which we are demonstrating through this video.
Mechanical steering gear. This was developed in 19th century when iron ships and steam propulsion emerged as rudders became heavier and larger. This system included chain and wire arrangement with gear mechanisms to reduce the effort required at the wheel. This is still used in launches or passenger ferries.
Steam-powered steering gear. This system appeared in the late 19th century and marked the beginning of power steering systems. This system used reciprocating steam engines controlled by the steering wheel, and the steam-powered actuator moved the rudder. This reduced the manual labor and improved the rudder response.
Ward-Leonard steering gear. The Ward-Leonard control system is an electrical method of controlling motor speed using a motor generator set and a variable voltage supply to a DC motor, which was developed in early 20th century. In steering gear system, the DC motor directly drove the rudder through reduction gearing. Speed and direction were smoothly controlled from bridge. It provided smooth and precise rudder control of rudder and had better response than steam system. Its decline started after 1940s when electro-hydraulic steering gears emerged which generate high torque.
Fully hydraulic steering gear. Fully hydraulic steering gear we developed in early 20th century and marked the birth of modern steering gear designs. They used hydraulic pumps with ramps which directly moved the rudder and proved reliable for merchant ships.
Electro-hydraulic system. Electro-hydraulic steering gear first appeared in the early 20th century and became widely used by the mid-20th century. It replaced the steam system, were bulky and less efficient. As the ships became larger, they required powerful steering gear with precise control. This system integrated electrical control with hydraulic power and enabled remote control from the bridge, reduced mechanical complexity, and improved precision and reliability.
Regulations for steering gears. Requirement about number of units. Every ship is provided with a main and auxiliary steering gear and so arranged that the failure of one does not render the other inoperative. When both units are identical, the auxiliary unit is not required. If rudder stock diameter is more than 120 mm in diameter, auxiliary steering gear should also be power operated. Protection against shock loading. Design pressure of steering gear component subjected to hydraulic pressure should be at least 1.25 times the maximum working pressure. Relief valve should be of adequate size and their setting pressure should not exceed the design pressure. Power and torque requirements. The power and torque capability must be such that the rudder can be swung from 35 degree on one side to 35 degree to the other side, with the ship at its maximum seagoing draft and at maximum ahead service speed. The time to swing from 35 degree on one side to 30 degree on other side must not exceed 28 seconds. The auxiliary steering gear should be capable of putting the rudder over 15 degree on one side to 15 degree on other side in not more than 60 seconds with the ship at its deepest seagoing draft and running ahead on half of the ahead speed or 7 knots, whichever is greater. Controls of steering gear. Control of steering gear must be provided both on navigation bridge and in the steering gear compartment. These controls also include audio-visual alarms for power failure and low level of hydraulic oil. A means of communication is provided between navigation bridge and steering gear room. Requirement of alternative power supply. When the rudder stock diameter is more than 230 mm, an alternative power supply sufficient at least to supply steering gear power unit associated control system within 45 seconds, either from emergency source of power supply or an independent source of power located in steering gear compartment. This is also applicable to tankers of 10,000 gross tonnage and above and other ships of 70,000 gross tonnage and above. Emergency power should be available for at least 30 minutes of continuous operation on tankers and 10 minutes on other ships.
Types of steering gear controls. Modern ships commonly use electro-hydraulic controls to operate steering gear. The steering wheel sends an electrical signal to a control unit which operates hydraulic pumps and actuators that move the rudder. It provides smooth, powerful, and precise steering action. Steering gear can be operated by any one of the three controlling modes.
Follow-up control. The rudder moves to a position corresponding to the wheel angle. Once the desired rudder angle is reached, movement stops automatically. This is commonly used method during hand or manual control.
Non-follow-up control. Rudder moves only while the control lever or the button is held. When released, the rudder stops immediately. This is typically used as an emergency or backup system.
Autopilot control. This uses a computer controlled system which keeps the ship on a set course. It uses sensors like gyro compass to adjust the rudder automatically. This reduces the workload of the navigating personnel during the long voyages and is employed mostly at the all times while the ship is at sea, except when the sea is very rough and adverse.
Local control or emergency steering. This is used if bridge control fails and steering gear is operated directly from steering gear compartment. It employs non-follow-up method and steering gear is operated by levers or pressing buttons.
We have made a model of 4-ram electro-hydraulic steering gear. The figure shows the hydraulic circuit diagram of the steering gear equipped with various components with the following functions. Oil tank holds hydraulic oil for its circulation in system. Air circulating around oil tanks absorb heat from oil and its temperature and viscosity is maintained within limits. A constant speed induction motor drives the hydraulic pump. Ship equipped with two motors are equipped with locking gear arrangement to prevent the reversing of electric motor when a single unit is operating. A fixed delivery hydraulic pump circulates oil through various components. Two hydraulic pumps are used on ship's steering gear which are usually of reversible flow with variable delivery. 4-ram hydraulic actuator is used to provide the turning movement of rudder. Two crosshead convert the reciprocating motion of rams into rotary motion of tiller arm to turn the rudder stop. 4 rams instead of 2 improve the response time and provide reliability of operation. One oil filter after the hydraulic pump and other in the return line are used to trap system dirt and wear particle and maintain system's reliability. Pressure relief valve protects the system from excessive pressure by relieving the pressure back in the tank. 4 ports 3 position direction control valve is used to control direction of rudder stalk remotely through solenoids. In central position, steering gear remains locked and oil returns back to the tank. In right position, P port is connected to A port supplying oil to cylinders 1 and 3. B is connected to T draining oil from cylinder 2 and 4 back to the tank. In this position, rudder moves in clockwise direction and the ship turns towards port. In the left position, P port is connected to B port, supplying oil to cylinders 2 and 4. A is connected to T and oil from cylinder 1 and 3 drains back to the tank. In this position, rudder moves in anti-clockwise direction and the ship turns towards starboard. Back pressure valve. Back pressure valve maintains positive pressure in the lines and prevents entry of air in the system.
This is the steering gear flat, typically just above the rudder, where all steering gear machinery and control mechanisms are placed.
This is the carrier bearing. It is the bearing which holds the rudder in the place. It also carries the weight of rudder. The weight of rudder is never on the tiller arm.
The rudder stroke. It is a shaft which is used to transmit the torque generated by the 4 cylinders to the rudder.
This is a rudder which works on the principle of Bernoulli principle, which is used to steer the vessel.
It is the pintle bearing. It is used to support the rudder and it is also used to prevent fluttering movement of rudder.
This is the hydraulic actuator, which is used to convert pressure energy of hydraulic oil into linear motion. This is the cord piece, which is used to connect tiller arm and ram.
It converts linear motion of rams into rotation.
This is the rudder angle indicator, which indicates the angle of the rudder along port side or starboard side. This is the
storage tank which contains hydraulic oil.
This is motor pump set. This is 3-phase squirrel cage induction motor. It is coupled with a fixed capacity gear pump. It provides high pressure hydraulic oil for movement of ram.
This is the dole starter for our 3-phase induction motor. This is the 3-phase line wire. It carries power to run motor.
This is oil filter. It is fitted in pressure line. It filters oil. This is pressure gauge. It is the component which shows pressure in the pressure line.
This is the relief valve. It prevents excess pressure build-up within the system. It also governs maximum allowable pressure in the system. This is a solenoid operated direction control valve which is used to give direction to the hydraulic oil with the help of electrical signals. This is the solenoid. It is an electromagnet. When electrical signals are passed, it is used to control the direction control valve.
This is the hydraulic hose, which is used to transfer the high pressure hydraulic oil to the cylinders.
Now we are going to see how this system works, and we will start the system and operate it. This is the motor starter. Here the green button is for start and red is for stopping. We start the motor. Motor will start running and we will get pressure here in the pressure gauge. We are getting around 10 kgs of pressure. Now these are the push buttons which will operate the solenoid valve and help the movement in rudder. Now we will see the movement of rudder from the other side along with the rudder angle indicator. Now we are moving the rudder in starboard direction. When the rudder hits the limit switch, it stops automatically. Now we will move it to port side.
I hope you enjoyed the demonstration. Feel free to share your feedback in the comment section. If you found this demonstration helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I'll be back soon with a new lecture. Thank you for watching till the end.